Hey Opties, what's up? So I think I've got this thing figured out to get us started here. As you can see, to get a maze in here, like you have on your Desmos assignment for this week, you just need to insert an image. So I made a really simple maze. If you might figure out, I tried to make it an O for Opto. I know that makes you very impressed.
So I think I've got this thing.
So, I want to start by reviewing the three types of equations of lines we've been talking about. The first one we started learning about is called point slope. And here's the equation for point slope. You've got y minus y1, where y1 is the y value of 1 point on the line. And then it equals the slope times the quantity. And when I say the quantity, that means that I'm putting parentheses there. And that's x minus the x coordinate that goes along with that y coordinate. So here's point slope form. And the reason it's got the triangle with the exclamation point is because it's saying, hey, I can't actually graph this, which is okay. I'm just trying to show you the formula. At any point during this live, if you have a question, you can put it in the chat, and I'd be glad to answer that for you all. So the next equation of lines we learned about is slope-intercept. So we just heard that M is the slope and B is the y-intercept. So M is the slope in both slope-intercept and our point slope. The third form we've learned about is standard form. And that is ax plus by equals c. Notice there is no m, so the slope is not just already written for us in the equation. A point is not already written for us in the equation, and neither is the y-intercept. And the thing is about these three equations, they're all different. And they all have different purposes that they're good for. One thing that is pretty quick to do with the standard form is to find your x and y intercepts. So an x-intercept always occurs where y is 0. So if you put a 0 in for y, then your x-intercept is going to be c divided by a, because you would just solve that equation for x. But if you put a 0 in for your x, you'd find your y-intercept. And then your y-intercept would be c divided by b, because your a times 0 term goes away because it's 0, and then you just have c over b. Okay, so we want to practice using equations of lines in all three of these forms. And we want to also practice using parallel and perpendicular lines. So let's remember that parallel lines have the same slope. Their slopes are equal. And that makes sense because slope tells us the tilt of a line. And parallel lines have the same tilt because if they don't have the same tilt, they're going to intersect. And parallel lines never ever intersect, so they never cross each other. Remember, perpendicular means that you intersect to form 90-degree angles. And for the slope of perpendicular lines, they are opposite reciprocals. Opposite reciprocals. Remember, opposite means you're going to change sign, and reciprocal means you're going to swap the location of numerator and denominator. And both of those have to be true in order to have perpendicular lines. And that's about the slope. Okay, enough talk. Let's do some stuff. I'm going to zoom in a little bit. Oops, I zoomed out. I mean to zoom in. Okay, so I know this is not a super hard maze. Like, you can start over here in the opening, and then you can just go through here like this. So you don't have to make that many lines to accomplish this, but I'll make sure we use a line in each form, and then some parallel and perpendicular as well. So let's start with a line in point slope form. So the way to figure out exactly what your slope should be is you can choose 2 points and then find the slope between those 2 points. So I'm going to start by plotting 2 points. Let's plot a point that I think looks kind of like at the opening of the maze. Let's say it's -2.5, comma, -1.5. So there's a point. We might want to move it a little bit to the left and a little bit down. Let's do -3 instead. And let's move it down to, I guess we can do -2 and see what that looks like. Okay, that looks a little bit better. So see how I did a little bit of trial and error here? Trial and error is a very good skill to use whenever you're doing this maze. Okay, so I'll label that. And now I want to pick a point that is at the next place I want to go to end my line. Like, this is just one strategy. You can pick the 2 points and find the exact slope, or you can just guess a slope based on, hey, is it positive or negative? Which means positive means the slope is going, the slope is positive and the line is increasing, which means it's going up from left to right. And then maybe you say, okay, well, I want a decreasing line. Well, that needs to be a negative slope. And then you can think about steepness or shallowness of the slope. If the line is super steep, you need a bigger slope. And if the line is not so steep, you need a smaller slope, maybe like a slope between 0 and 1. So like 1/2, 1/3, 2/3, stuff like that. But for now, let's pick the 2 points and find the slope exactly, because you might like that method. And then I'll show you the little bit more trial and error. So let's pick a point maybe around here. That looks like -2, comma, -1/2. That looks pretty good, and I'm going to label it. Okay, so let's find the slope. So the slope is the change in y divided by the change in x. So I'm going to go ahead and set up a fraction bar. All I did was press the division symbol. You can press it on your actual keypad like I did, or you can click it on the screen. And let's start with our numerator. So I'm going to do -1/2 minus -2. And I started with that bottom y value. Bottom as in like this, I typed it in second. In the picture, it's actually on top. So whatever you want to think about. It doesn't matter which one you start with, as long as that the point you start with at the first, the point you start with in the numerator is the same point you start with in the denominator. So minus -2. Okay, so that's the change in y. And now we have to start with the -2 because that belongs to the point that we used at the beginning of the numerator. So -2 minus the -3. So the slope is exactly 1.5 for the 2 points that we have. So we have a point in the slope. So a really nice equation to use would be point slope form, because when you have a point in the slope, then to me it's like the easiest is point slope form. So let's do that. So we're going to do y minus one of these y values. So let's just pick the point -3, -2. You can pick any point on the line, and I just would probably rather deal with integers than some decimals. Like, I don't want to really deal with the -1/2, which is not like a crazy number or anything, but I just kind of like this better. So if we're subtracting the y value, then we're going to subtract -2. And then we're going to equal the slope, which we just found to be 1.5. And then we have to do our quantity of x minus the x value. Okay, so here we have it. You see how it goes exactly between those 2 points. If you want to, you can change the minus minus 2 to a plus and the minus minus 3 to a plus. Okay, so we have a nice line, and we have like a little bit too much line really, because we've got the line going on for forever and ever. And when you're doing a maze, you don't just draw a bunch of full-length lines everywhere, right? You're going to draw a bunch of line segments. And of course, you may not draw straight line segments. You might do some curves when you're actually doing a maze by hand. But for our cases, we want to practice using linear equations, so we are doing those straight lines. But regardless, you're not going to have a forever going line. You want to have line segments instead. So the way we can change this into a line segment is we can make what is called a restriction. So if you think about the word restriction, it's like kind of like rules, maybe limitations. There's certain places you can't be, certain things you can't do. So we're going to make it where there's certain places this line can't be. So we want to either restrict the domain or we want to restrict the range. So domain is talking about all the x values that are possible, and range is talking about all the y values that are possible. So if we restrict our domain, again, which is x values, we're going to cut off the left and the right. If we think about it as restricting our range, we're going to cut off the bottom and the top. So let's just start with domain. So if you're going to do restrictions, you're going to use these curly braces, and it'd be good to either make yourself a note of the 2 x values you're going to use, either in like a new line, or if you have your points plotted, then it'll still show up there for you. The reason I say that is because as soon as you type something in your curly braces, like I've just done here, your line disappears, and if your line's not there, you won't be able to click on your line and see the point. So like a lot of times, if I'm doing a lot of trial and error instead of just finding the slope right off the bat, I'll click on the line and drag it around to see which point looks nice, and then I'll just use whatever I see. But since we have our exact points, we know exactly what we want to use. But if I didn't have my points labeled, I might just go on this line here and say -3 is going to be my furthest x value to the left that I want, and the furthest x value to the right that I want is -2. So I might make myself a note. And then I would know that I have to do x greater than, because -3 is the smallest x I want, the most left x, and that's going to be greater than x, but x is at the same time going to be less than the biggest x I want, which is going to be -2. So I'm going to do another less than -2. So now I don't really need this entry anymore because I've already got my restriction written. Okay, so again, this little part of the statement, part of this inequality or our restriction, says that x is greater than -3. And the second part says x is less than -2. And another way to read this, which I think is probably my favorite, is x is between -3 and -2. Okay, so there's one line. We've used point slope form. Let's make a perpendicular line, because I bet we could make a perpendicular line without intersecting this purple line here. I bet we can make a perpendicular line to practice that slope, and it would still follow the maze. So let's do that next, and I say we use slope-intercept form. Let's try that. Or you know what? Yeah, let's use slope-intercept form. Let's use slope-intercept form. Okay, so if I am being asked to write an equation of a line that's perpendicular to a given line, probably the first thing I do is identify the slope of the given line and then find a perpendicular slope to that, because that's one of the main things you have to write that line, okay? That's what makes it perpendicular. Of course, you need to have maybe a certain point to go through, unless it doesn't specify, unless it just really just wants only to be perpendicular. But so let's figure out the slope of our given line. We know that it's going to be this m, which is the coefficient of our x term. Like if you distributed, you would have the 1.5 or 1.5 be right on the x to be the coefficient. And you can also go back and look at your point slope form, and m is in front of the parentheses, okay? So 1.5, which is also 3/2, is our slope, okay? So I'm going to make myself a note here. The slope of the existing line is 3/2. And again, we're just doing perpendicular just to practice. So remember, perpendicular slopes are opposite reciprocals of one another. So let's start by making our negative 3/2. I'm so sorry, not negative 3/2. Our positive 3/2 be opposite, which I kind of gave it away. Opposite means to change the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. So it is going to be negative 3/2. And now let's make it be a reciprocal. So we're still going to have the same sign because we've already taken care of the opposite. And now we're going to swap the location of numerator and denominator. So our new numerator needs to be the existing denominator. So our new numerator is 2. And our new denominator is the existing numerator, so it's going to be 3. So negative 2/3 is the perpendicular slope to our green line we've already graphed, okay? So let's use this slope, and I'm going to go ahead and just delete the rest. So we're going to use this slope. Let's start by doing y equals, because remember, we're deciding to do slope-intercept. Y equals negative 2/3 x. So now we see that the slope is there. You know, our line is there. It's way too far up, though, because we want to go and intersect this point, the red point. So we want to kind of keep our ends close to each other. So let's just start doing some trial and error, because that works really well sometimes, the guess and check method. It looks like to me it's going to have to move down at least to negative 2. So let's just see what happens when we do a negative 2 y-intercept. That was pretty close. It's still a little bit too far down. So let's move it up a tad. Maybe we do negative 1.8. That's still it's pretty good. I'm going to zoom in a little bit to see quite how good this is. So I know I zoomed in a lot. I have to kind of drag. So you can click and drag and see that's pretty good. I might try to make it like slightly better than that. So we need to move it down a little bit more. So let's do 0.85. Too much. 0.83. How about 835? That's pretty good. And you know, this is like a little bit extra. I'm going a little bit crazy here to make it exactly on there, but it just makes me all excited whenever they're really, really close. And it's still slightly off, y'all. Let's just do 4. Oh my goodness, it looks so good now. I think so. Okay, so I'm going to go back to home, which means it goes back to like 0, 0 is like the middle of my screen. And you can tell it looks pretty darn delicious. Looks real beautiful. Okay. So we've got it intersecting that point, and let's say we only want to go down to like here-ish. Maybe negative 1 would be good. Just to keep numbers nice. I mean, you don't have to. You can make crazy decimals like I just did, the negative 1.834 or 834 thousandths is how you technically say the number. You can do those big decimals. That's fine. But if you want to find like maybe the 1, the 1.5, the 5.5, you know, you can do that too. So we want our biggest x value to be a -1, and our smallest, if we're intersecting that point, it should pick up where the other one left off. What I mean is the ending point of the other one was -2, so this one should start at -2. So let's try that. Okay, we got more curly braces. Uh-oh, I messed something up. Let me undo. I think I just made like a bunch of cells for some reason. Okay, here we are. Okay, curly braces. And it's -2 to -1. Now those numbers aren't like hard to remember, so I might not make myself a note and I'll just do it. Okay, so that looks pretty good. And we did make it perpendicular, so that's good to practice. This next time, let's try to do, maybe let's do a parallel. Since it looks like we're going to go back in the direction that the green line is, let's do parallel to the green line. Not to the black line, but to the green line. And let's make it, let's try to do standard form. To me, the standard form would be my least favorite because I just don't think it's as intuitive personally, but let's try it. So we know the slope has to be 1.5, which is the same thing as 3/2. And if you remember, the slope of a standard form equation is -a divided by b. So we know the slope needs to be 3/2. So to know exactly what number needs to go on the a and exactly what number needs to go on the b, our numerator needs to change sign. So it should be a -3 for the a, and the b should be 2. I think I'm doing that right. Let's try it. Uh-oh, not x, y. And let's just put it equal to a number first. Yes, you can see that they're parallel. If we try it, like if we tried to solve this equation for y to like get our coefficient of x to do our slope, because that's where you get -a over b, you would add 3 to both sides, and then you divide both sides by 2, and then you get 3/2. So that's a good check that, hey, that is parallel slope. Okay, so let's investigate with some guess and check. What does our c value, our constant, which is currently 6, what's that do to our line? So it's 6 now. Let's go to 10 and see what happens. 10 makes it go up and left, okay? So maybe we want to go 3, so we're going to go down. Okay, so we're going down. Let's make it 2. Because, see, I'm trying to inch towards the end of that black line. Let's make it 1 now. Maybe not even 1. Okay, let's try 1.5. I think I might be going the wrong way. Yeah, that's the wrong way. Let's do 0.8. That looks pretty close. Again, I'm going to zoom in to see how close I really am. See, as you zoom in, you see it's like slightly off, which is really not a huge deal, but we can probably afford to be a little bit more precise. Okay, so let's try. See, I'm going the wrong way. I have to make it smaller. 0.7. That's pretty close. It looks pretty good to me. 0.7 is the same thing as 7/10. So if you really wanted to write it as a fraction, I'll just do that just to show you. You can do that. It's up to you. Okay, so it looks pretty good. Now we can go about restricting our domain or range. And since we've done 2 restrictions of domain, remember that's your x values. I want to restrict our range this time. Okay, so I'm going to go back to home just to kind of like visualize the whole picture. And it's a little bit too zoomed out for me at this point, so I'm going to zoom in a little bit. Okay, that looks pretty good. So let's kind of click, because we know we can start our range at this point. Because on range, I want to go from the smallest to biggest, and that's going to look like the bottom to the top. Smallest to biggest for our domain is left to right, but for range, it's bottom to top, and we're going to use Y instead of X. So we've clicked here, and then we see our Y value, and that's a funky looking number, so I'm definitely going to make a note of this. So negative 1.162. Okay. Now let me click and kind of figure out where I want to go next. So maybe I'll go up to here, and that Y value is negative 0.391. Okay, so let's make our curly braces. Y'all, I keep putting the wrong button, and then everything goes cray-cray. I think I'd keep doing like control instead of shift. I don't even know. Like, look at all these empty cells I got. Okay, here we go. Perfect. So maybe I put enter. I think that's what I keep doing. Okay, so actually, I don't know why I haven't done this before, but why wouldn't you just highlight this, copy and paste it? And I wasn't going to cut it. I was just going to copy it in case something crazy happens and I lose them. So less than Y. And I keep using my keypad, but you can also just click on the screen. I know that, like, I think on your pumpkin Desmos, the first entry, which is like an example, uses one of your inequality signs as a less than or equal to. You can use that if you want. You can use one less than or equal to, both less than, or both less than or equal to. It won't matter in what you see. What will matter is, like, for example, if you go to the very end of this line, for the black line, or any line really, if it'll let me click on it. See how it says undefined? That's because it's not an or equal to piece. But it still will look like you're going there. So whatever works for you. Okay, so we've got that. I will delete this line. So we've done one of each type of function. Not function, sorry. One of each type of form, because they're all linear functions. We've done some calculation of slope from 2 points. We've done, given that point, we've done perpendicular slope, which makes the whole line perpendicular. And then we've done a parallel slope. Let's do just a regular old line. And let's start from where we ended up. Let's try to intersect our red and go down. And then we'll come back up, go down and out. So maybe we can get by finishing 1, 2, 3, 4 more lines. Okay. And there's several ways you can go. You could go up and then up to the right, and then down, then right. It's up to you, but let's just go down, I guess. So I'm going to show you how to kind of work this with a guess and check method, more like, because everybody's personality is different, and I know there's lots of different ways to do math, so I kind of want to show you how it would work if you just kind of guessed and checked. So, for example, since we're close to the y-axis, it might be a good time to use slope-intercept form. And different forms work better or worse than other forms in different situations. So I'll zoom in a little bit. Okay, so the slope needs to be negative because I'm going down. It'll be decreasing. So let's just start with y equals negative, and it kind of needs to be like a little bit steep. I don't know, maybe -2, so probably bigger than 1. And I have to put the x for it to show it to me. That actually looks like a pretty good slope. Now it's too high up, so I want to move it down, which means I need to make my y-intercept be negative because the current y-intercept is 0. So it looks like maybe -1 might be good. It's probably a little bit not low enough, but we'll start there. And here's the idea. Like, you're just kind of like looking at the graph and making an estimation at the beginning. And now you can say, okay, I need to go a little bit more down. So let's just do -1.5. That's too much. So take it away a little bit. And that looks pretty good. Okay, so that might be a little quicker for you. You might enjoy that more. I mean, that really actually was like really good. I think it right intersected that exactly, which is kind of beautiful. So let's make a note of our 2 points. I suppose we'll do another range restriction because we have been doing the domain twice and we've only done the range restriction once, so I will do another range restriction. So the smallest y value is -1.4 because it's the bottom. And I just picked this random point that, I say random, it's the y-intercept. You don't have to pick that point. I just picked the point that it showed up. But it actually is probably a pretty good point to make a turnaround to go back up to bypass this circle in the middle. So let's just pick that one. If you wanted to like go further down for some reason, you could just click and drag and find the point that you need. But let's start here. So we've got -1.4. So -1 2/5 or -1 4/10. And then the biggest y value is maybe, what was that? -0.4. Okay. I'll make my curly braces. And I think I'll copy and paste like I did last time because I think that worked pretty well. And we want to do, that's our y value, so we're going to put a less than, here, I'll do less than or equal to for y'all, just to show you that, I mean, it works just fine. You may like that better, and I didn't do my y. And here we go. Okay, so I'm going to move my screen slightly. Looking beautiful, looking beautiful. Okay, so we've got that. And like, here's what it means if you do less than or equal to. If you go all the way to the end, it shows you that -0.4 number. And it shows you this -1.4 number. But if you look at the red line where we had the not or equal to portion, it should show you, well, maybe I'm not getting quite there. Well, we showed a minute ago how it said undefined. Let me try to show that to you. Maybe this black will show up for us. Yeah, see how it says undefined? Because if you go back here, both of these are less than. They don't have less than or equal to. But it still looks like just fine. So it's fine to do that. It's whatever you want. You can put or equal to or just a less than. I bet we can get by with 2 more lines, y'all. I bet we can. I'm going to do another point slope. And I'm going to calculate the slope. Let's do that again. Because if we go up further enough, we could do a really shallow line or even a horizontal line. I'll do that in the end. A horizontal line to get out. So let's do 2 more. So let's pick 2 points. I'll use that point because that's where that one ends. 0, -1.4. I'm going to go ahead and plot it. And then I'm going to go up to, let's say, of course it won't let me, unless a line's there, it won't let me actually click and drag to see a point. But if I go up to this far, then I can go make a horizontal line straight out the gate. That looks like 1, 2, 3, 4, 4/5. 4/5 for our x, and which is 8/10 or 0.8. And then it goes up maybe 3/5, which is like 0.6, 6/10. So let's go 0.8 comma 0.6. And let me explain again how I came up with those numbers. Yeah, exactly what I was looking at. Okay, so the way I came up with those numbers is from the 0 to the 1, there are 5 little boxes, okay? And I wanted to go 4 over, so that's 4 out of 5. And if you multiply the numerator and denominator by 2, you get to 8/10. So 4/5 is the same thing as 8/10, which is 0.8. I just wanted to do it as a decimal. That's why I converted it to tenths. Similarly, for the y values, there's 5 little chunks between the 0 and the 1, and we went up 3, which is 3/5, aka 6/10, which is 0.6. Okay, so that's how I did that. So now let's find the slope. Let's set up our fraction bar, and we're going to do the difference between the y's divided by the difference between the x's. And while I'm typing this, I'm going to move my screen so we can actually see it, the points still. So let's start with the top point, because last time we started with the bottom. And when I say top, I mean the one that's written first, because I like to visualize it right here on the same left-hand side of my screen. So let's do negative 1.4 or negative 2/5, negative 1 2/5. Minus the other y value, which is 0.6 or 6/10 or 3/5. Now let's go back to our top point, which is 0. 0 minus, well, the x value is 0. 0 minus 0.8. And all I'm doing is finding slope, okay? 2.5. Great. So that's our slope, and we have 2 points and a slope, so we can use point-slope form. Okay. I think I might use the 0, negative 1.4 number or point, because it's got a 0 in it, and when a 0 is in there, it makes it like easier to write equations. Because, you know, it's just a little less to write. And plus, I haven't shown you one like that in point slope with a 0, so let's just do that. It looks slightly different when it's the x value or the y value is 0 in point slope, so I just want to show that to you. Okay, so we're going to do y minus the y value, which is negative 1.4. Okay. And then we have the slope of 2.5 times the quantity of x minus the x value. Now, x minus 0 is just x, right? So you don't even have to have the parentheses there, because this is exactly the same thing as just having the x there. So that's really the final way to write it. Well, I say the final. You can also make this minus minus be a plus, and let's do that. So this is in slope-intercept form. I mean point-slope, my bad. That is in point-slope form. There are no parentheses because the x value is 0. So that's what it looked like if your x is 0. Let's say your y was 0, just for kicks and giggles. Then you'd have like y minus 0 equals, let's say the slope's 5. And I'm just making this up. So here's your line. That's the same thing as taking off the minus 0 from the y. So that's also in slope-intercept form. Oh my gosh, said it again. In point-slope form, just looks slightly different because the y value is 0. So I'll take that off because that's just a random. But we have this, and now let's do our, let's go back to domain, I suppose. It doesn't matter. Let's do our domain restriction. Since our points are plotted, it's really easy to see those numbers still. Okay, let's make our curly braces again, and our furthest to the left number is that 0. So x is going to be greater than 0, and I'm going to throw in a less than or equal to piece, you know, just because. And then we go up to the furthest to the right x we want, which is going to be 8/10. And there we go. It's beautiful. Okay, we're almost done, y'all. I'm going to go back home for us to see what we got going so far. Isn't it so pretty? I'm just so excited. I know y'all love it. Now, finally, let's do a horizontal line because we can go straight to the right and get out of this maze. The horizontal line that we should use is really whatever the y value is at that point, which is the 0.6. So let's do that. Y equals 0.6 because we know it's going to be exactly aligned with that point. Any horizontal line is always going to be y equals a number, and any vertical line is always going to be x equals a number. For horizontal lines, your slope is 0. So another way to write this is 0x plus that. That'd be your slope-intercept form version of this. Okay. If you wanted to do a point slope version, it'd be like this. And then you just have a flat out 0 on this side. It could be 0x. Either way, your x or your slope is 0. I'm just undoing all of this stuff. Go back to just our y equals 0.6 or 6/10. There we go. Put a 0.6. Some people like to see that. I don't really care, but it's up to you. Same number. Okay. Now what's interesting about this is you cannot restrict your range because there's only one number for the range. The range is always just 0.6 for this one. You don't have any height to it at all. It's just a flat line, right? So we have to restrict our domain here. And let's say we did use a vertical line in this maze, which we certainly could have. Sorry, I got out of frame there. Like if we did a vertical line, it could be, I don't know, x equals 1. We could only restrict the range for that because there is no width to it. There is no left and rightness. It's just that y equals 0.8 forever and ever and ever. Or I said 0.8. 1. Sorry, I was looking at 0.8 point we got there. Okay, so let's finish out real quick. We want to go from the smallest x value, looks like a 0.8, and then let's finish out at, I'm just going to click and drag. Let's finish out at 3.2. Yeah, so 0.8 and 3.2. Let me make myself a note because I'll forget. 3.2, I believe. And now let's make our curly braces. And I will copy. Paste. And it's going to be less than x, less than x. Well, I mean, that's those symbols I'm writing, but it really reads x is greater than the 0.8, and then x is less than 3.2. And again, you can also read that as x is between 0.8 and 3.2. And that just looks so beautiful, am I right? It makes me so excited. Let me hide my point labeled, my points that are labeled, just so we can see the maze solved itself without all those extra numbers. Okay, there it is. Looking gorgeous, looking gorgeous. Okay, so we're done with the maze. We've done parallel, perpendicular, point, slope, slope, intercept, standard. We've calculated the slope from 2 points. We've done guess and check with thinking about is it increasing or decreasing, which means does it have a positive or negative slope? Does it need to have a steep slope or a shallow slope? Do we need to move it up or down by manipulating our y-intercept? I do want to just chat real quick. I didn't show this, but this is a good method to use. Let's say you're looking in this area of this green line before you've made the line. And you say, okay, well, a point that here along the line where I'm visualizing the line probably should go is, you might think, oh, it looks like maybe 0.5 and negative 2.5 or negative 0.25, okay? you're just like, this point looks like it goes there. You can use that point in a point slope form, and then once you've plotted it, you can then guess and check your slope. So that might be a good thing to use. There's lots of different methods to use here. It's just depends on kind of what works for you. I'm going to go back to home, and I'm going to wait a few minutes to see if anybody has any questions. I really like the method of restricting your domain and range because you can make really pretty pictures. I made the maze like on I just made the picture and then I just put the image in here. So I didn't use Desmos to make the maze itself. But I've made pictures on Desmos before. If you go to the Desmos website, just like typing in Desmos on your browser and clicking on it, if you start scrolling on like the very first page, they show you all kinds of insanely beautiful art that people have made. Like, it's crazy awesome. I've made a few things on there before, but some people just go all out and they do shadings. If you do inequality functions, like here, let me show you an example. Let's change one of these to be inequality. Like, instead of saying equals here, I can go make this y, the whole function, be less than, and see how it shades below that? If you use shading, then you could make some things to be like super artsy like, and people use that. Like, you can even graph a circle and then shade on the inside or outside of the circle, and then you can make a colored in circle, or you can shade on the outside and it's like everything is colored in except for the circle. So there's so many cool options, and you can do functions other than just linear functions. So you can do curves instead of just lines and make things like super awesome. So okay, I think I'm done with everything that I think that would be a good review for your maze project or maze assignment. I'm just gonna hang out for like maybe another minute in case anybody has any specific questions. So if you do have a specific question, please put that in the chat so I can see that and I can address your question. All right, Opties. So I don't see anybody that has questions. And I said all I've got to say, I believe. So I will see y'all next time. Tune in next time.